What happens when you can buy a fully functional humanoid robot for 16,000 bucks? Seriously, that is roughly the annual cost of a minimum wage human worker in the US. I know, it sounds totally like science fiction, right? But it's actually not. This is a very real, massive economic shift happening literally as we speak. Welcome to This Explainer. Today, we are unpacking an unprecedented convergence of technologies that are quite literally restructuring our entire global economy. Our big overarching theme for this explainer is the year 2026. You know, experts from Day and McKinsey are heavily pointing to 2026 as this monumental tipping point. Ever since ChatGPT dropped, it kind of feels like we've just been watching AI do really cool parlor tricks. But major tech transformations, they don't happen overnight. First, you've got to build the infrastructure. Yesterday, it was laying internet cables. Today, it's sprawling data centers, satellite networks, and robotics. And by 2026, these exponential technologies are fully leaving the R&D labs and hitting the real world. Now, synthesizing these really dense industry reports from places like the ITU and McKinsey takes a ton of research hours. So if you're finding this explainer valuable, please take a quick second to hit that like button and subscribe to our YouTube channel. It honestly really helps us grow and makes sure you never miss out on understanding the future of tech. Okay, let's dive into our roadmap for today. We've got 1, the 2026 tech tipping point. 2, the new robotic workforce. 3, quantum computing and 6G. 4, the evolution of mobility. And finally, 5, regulation and human impact. Let's get into it. First up, Section 1, the 2026 tech tipping point. We're moving from simply answering questions to taking real autonomous action. According to Asade's forecast for 2026, the trends we are seeing are just wild. We're moving toward AI agents that don't just chat with you, but actively buy goods, negotiate deals, and manage complex business processes. And get this, we are actually seeing AI models, like the collaboration between NVIDIA and StarCloud, successfully training in Earth's orbit. They're turning space into a literal new computational frontier. Down on Earth, real-time simultaneous translation from giants like Apple and Google is making language barriers completely obsolete. And maybe the craziest part, AI agents are now acting as non-human researchers, experimenting and discovering totally on their own. The real competitive advantage is rapidly shifting from finding scarce human talent to artificially scaling it. Moving right along to Section 2, the new robotic workforce. Let's look at how we are actively solving massive labor shortages. What's really fascinating here is the sheer economics of it all. We're looking at a projected global shortage of 8 million manufacturing workers by 2030. So let's break down the pure, unavoidable math to solve it. Just between 2022 and 2024, the unit cost of humanoid robots plummeted by at least 40%. The Unitree G1, for instance, starts at around $16,000. And remember, that is a one-time purchase. Compare that to the annual cost of a human worker, which usually runs somewhere between $45,000 to $75,000 plus benefits. The robot works 20 to 24 hours a day, which brings its effective hourly cost down to a staggering $3 to $8. It takes 0 sick days, it needs no workers' comp. That economic crossover point where robots literally become cheaper than human workers, it is arriving right now. And listen, this isn't just academic theory. Massive legacy automakers are actually trusting bipedal robots on their assembly lines today. BMW has already deployed Figure 02 robots at its Spartanburg facility for handling parts. Mercedes-Benz partnered up with Apptronik to test the Apollo robot for heavy material transport. We're talking about carrying up to 25 kilos around the factory floor, right on schedule. Plus, they take natural language instructions, so training them is honestly becoming a lot more like managing a person than coding a machine. Just, without the workplace drama. All right, Section 3, quantum computing and 6G. Let's talk about the brand new unseen infrastructure that's making all of this possible. Before we even touch the quantum stuff, just look at the massive scale of standard AI infrastructure. Global generative AI enterprise spend is forecast to explode from $4 billion in 2025 to a totally astounding $19.2 billion by 2030. We are officially leaving the era of cute little tactical pilots, entering the era of massive, enterprise-wide transformation. But standard computing definitely has its physical limits. And that's exactly why business leaders are pouring absolutely massive amounts of money into quantum computing. McKinsey projects that by 2035, quantum computing could create up to an eye-watering $2.7 trillion of economic value worldwide. It's a completely new paradigm that uses the laws of quantum mechanics to solve complex problems that traditional computers literally cannot touch. Now, to connect this new quantum reality to our fleets of robots and smart devices, the UN's Agency for Digital Technologies, the ITU, is already finalizing the framework for 6G, which they call IMT 2030. They have outlined 20 specific technical requirements. But here's the thing. This isn't just about getting faster download speeds for your phone. The ultimate goal here is ubiquitous, immersive, and highly resilient connectivity. They want to create networks so affordable and so robust that they actually close the global digital divide and stay online to coordinate disaster response when everything else fails. This is where the underlying science gets truly mind-bending. Researchers are aggressively moving beyond the traditional physical limits of silicon chips. They're doing things like creating optical tornadoes, literally swirling beams of light to twist quantum communication. Engineers have built phonon lasers that generate incredibly tiny, microscopic earthquake vibrations to shrink electronics down. They're even designing shape-shifting molecular devices that can act as memory or logic right within the exact same structure. We are talking about hardware evolving at a fundamental atomic level. Let's pivot to Section 4, the evolution of mobility. How all this tech translates into how we physically move around. An absolutely crucial bottleneck for all of this has always been energy storage. But check out Toyota's all-solid-state battery prototype. They are laser-targeted on 2026 to introduce next-generation batteries that will offer a cruising range of 1,000 kilometers and an incredibly quick charge time of 10 minutes or less. By completely innovating the battery chemistry, they are basically trying to eliminate range anxiety for good. But it's really not just about the battery itself. It's about how the entire car is actually built. Toyota is totally reimagining the factory floor. We are moving away from the conventional suspended assembly lines of the past towards next-generation self-propelling lines. They are using something called gigacasting, which is molding enormous sections of the vehicle in one single go to eliminate thousands of tiny parts. Then, they just let the partially built cars literally drive themselves to the next assembly station. This eliminates conveyor belts entirely and cuts both production lead time and factory investment right in half. They are also completely rethinking the microchips inside the vehicles themselves. By swapping out standard traditional silicon wafers for silicon carbide power semiconductors, Toyota is actually aiming for a full 10% improvement in vehicle efficiency. Literally, every single component is being optimized to squeeze out more performance. And when you zoom out from passenger cars to global freight, the implications are just massive. ESAID points out that autonomous trucks, paired with cheaper and much longer-lasting sodium batteries, will radically reduce logistics costs. Think about it. They don't need to pull over to sleep. They can drastically shorten global supply chains and cut down on inventory overhead, which generates huge advantages in overall industrial competitiveness. Which brings us to our final section, 5, regulation and human impact. How are we actually preparing society for this shift? Let's map out how the legal framework is actually trying to keep pace. The European Union has laid out arguably the most comprehensive regulatory roadmap to date with their AI Act. Notice the timeline here. The initial prohibitions and AI literacy requirements kick in right around early 2025. Governance for general purpose models follows closely in August 2025. But the really massive date to circle on your calendar is August 2026. That is when the AI Act becomes fully applicable and member states have to have operational national AI regulatory sandboxes. The law is actively forcing companies into compliance for this exact 2026 tipping point. Okay, so what about our jobs? Well, the World Economic Forum estimates that while automation may displace around 85 million jobs by 2030, it's also going to simultaneously create 97 million entirely new roles. So we really aren't looking at total human replacement here. It's about powerful augmentation. Entirely new career paths are emerging as we speak. Think titles like robot fleet manager or AI trainer. The tasks that will remain firmly in the human domain are the ones requiring deep creative problem solving, high emotional intelligence, and complex relationship building. Now, a quick warning, this transition won't be perfectly smooth. Current industry data actually shows that about 30% of generative AI enterprise projects are just totally abandoned due to poor data, unclear value, or just a sheer lack of governance. The companies that are actually going to thrive in 2026 aren't the ones just blindly buying the shiny new technology. They're the ones doing the really hard, unglamorous work of organizing their data and training their human workforce to collaborate directly alongside AI. So, bringing it all together, the 2026 tech tipping point, It isn't just a bold prediction anymore. It is a scheduled arrival. The 6G and quantum infrastructure is actively being built. Major automakers are completely overhauling their factories and literally hiring bipedal humanoid robots today. And international regulators have already etched these compliance dates into hard law. This grand convergence is happening, and it is going to rewrite the fundamental rules of productivity. Which really leaves us with one final, absolutely crucial question. How are you and your business actually preparing to augment yourselves for this radically new reality? Let us know your thoughts down in the YouTube comments. And hey, if this explainer helped you grasp the massive shifts coming our way, please hit that like button, subscribe to our channel, and we will see you in the next explainer.